Hey guys, we're going to do a little video lesson here on the introduction to proofs. Specifically, we're going to be looking at the algebraic relationships that exist within linear equations, and we're going to kind of verify these relationships as well as kind of show you how proofs are going to work as we continue through geometry this year. So the first thing you're going to recognize at the top of your notes here are that there is a set of concepts that you guys learned back in Algebra 1. And these are all the properties dealing with equality of real numbers. Equality of real numbers. So remember, what we're talking about here is looking at linear equations, and we're going to use these properties to kind of explain what we're doing in each of our steps. So let's kind of just review from last class and kind of walk through some of these concepts and properties. The first one listed is the reflexive property, which states for every number A is always equal to A. Now that should make a lot of sense and be pretty intuitive to you, that if I'm given the number 4, I know 4 is always equal to 4. Alright? Because that's always true, we can also think about it as like 4 is also equal to 2 plus 2, right? So that reflexive property can be manipulated and used in different ways to help us understand the relationship between 2 or any number. The second one is the symmetric property for all numbers A and B. If A equals B, then B equals A. So basically it's saying if I'm given the equation like 6 equals 3x, and if I were wanting to solve that, and I'd like to have my x's on the left-hand side, I could do that by the symmetric property. I could just change that to 3x equals 6. And we know that those are the same statement. Second is the transitive property for all numbers A, B, and C. If A equals B and B equals C, then we know A has to equal C. So what's an example of that? Well, let's assume that we know x equals y. And we also know that y is equal to negative 3. Since x is equal to y and y is equal to negative 3, by the transitive property, I can conclude, therefore, x would have to equal negative 3. Alright. The next property is the addition subtraction property, which states that if for any number a, b, and c, if a equals b, then a plus c is going to equal b plus c. And, on the same side, a minus c is going to equal b minus c. So let's say you were given the equation like 3x minus 6 was equal to 2. If you were solving this equation, you would probably phrase it in a way of I'm going to add 6 to both sides to combine like terms on opposite sides of the equation. But the real question is, why can I do that? It's really because of this addition and subtraction property. Because I have a negative 6 here, to keep the scale balanced, I'm going to go ahead and subtract 6, and I'm going to add 6 to both sides of the equation. And I can do that because of the addition and subtraction property. Now, what we're really interested in is then negative 6 plus 6 becomes 0 because of the additive identity property. But for right now, this is good enough. Next is the multiplication and division property. For all numbers a, b, and c, if a equals b, then a times c is equal to b times c. And if c is not equal to 0, a divided by c is equal to b divided by c. So where is an example of this? Well, if you had 3x was equal to 6, just as an example, that would also be similar to 3x divided by 3 is equal to 6 divided by 3. That division property is helpful when trying to isolate x with a coefficient of 1. Substitution property for all numbers a, b. If a is equal to b, then a may be replacing b in any equation or expression. So this is really helpful when we're talking about systems of equations, but let's just say r is equal to 9, and we're given the function or an equation where 3r is equal to 27. What I can do is I can go ahead and plug in, or substitute, 9 in for r. And we know 27 equals 27 by the reflexive property. Our last property that we're going to review is the distributive property. For all numbers a, b, and c, then a times the quantity b plus c is equal to a times b plus a times c. And just to look at an example of this, sometimes we're given that a number like 3 is multiplied to the expression x plus 2. And the distributive property basically says I can bring that coefficient or that number outside my parentheses, and I can multiply it to every term within the parentheses. So if I bring the 3 in, this is going to be equal to 3x plus 3 times 2. Or, simplifying that, goes to 3x plus 6. Alright? So let's just look at an example of how they want us to set up a proof. And we're going to look at it using these different properties of algebra. So a proof ultimately is a set of logical steps and reasons for how you got to a conclusion of what you're trying to find. It's a really simple explanation of what a proof is. So if we were asked to solve the quantity 3 times x minus 2 is equal to 42, if I was asked to solve that, the first thing that I would always want to write down is the original equation that they gave me. So here's my equation, and I write that down my first step. The property or the reason that I wrote that down was because that was my original equation or my given information. We're always going to start with the given information that they give me. Now, once I do that, I have to think about my steps logically. What would I do next? Well, I would distribute the 3 into the x and the negative 2, and I would get 3x minus 6 is equal to 42. What was the reason for that? Well, the reason was I used the distributive property. Next, I have a negative 6, so what I want to do is I want to add 6 to both sides. To do that, I'm going to make sure that I add 6 to both sides of my equation. And when I do that, that's the addition property. I can combine like terms then and get 3x is equal to 48. And then I'm going to use my division property to divide by 3 on both sides of the equation. And I find my final answer, because after 48 divided by 3 is simplified, I get x equals 16. So remember, proofs are just that logical steps and reasons for why an equation can be solved or why something equals something else. Alright? So let's look at our first example here as a class. Remember, whenever you're doing video lessons with me or with somebody else, or also even with Khan Academy, you always want to make sure that you're understanding as you progress through the video. So at any time, if you feel like you're understanding it faster than I'm going, just go ahead and fast forward a little bit. But make sure that if you ever get confused or lost, you rewind and pay close attention to the details of which I'm going through the steps. Alright, so the first thing we're always going to do in a proof with my statements and my reasons is, number 1, I'm going to go ahead and list the given information. So here they give me this equation right here. So I'm going to rewrite this equation in the statement line. 2 plus 2x plus 3 is equal to negative 5. My reason for writing that step, or that statement, is that it was the given information. We're always starting with the given information first. In step number 2, what I'm going to do here is I'm going to look at to see what am I going to do first in this process. So the first thing that I would do algebraically is combine like terms on the same side of the equation. So since there's a 2 and 3 here, I'm going to add 2 and 3 together and get 5. So now I'm going to write my equation as 2x plus 5 is equal to negative 5. Now, the reason is exactly what I just said, but just writing it out in words. I'm combining like terms. And there's always a reason for everything that I do, and that's why we set up a proof. Step number 3. Next thing I'm going to do is probably that additive property, the addition property. So I'm going to have 2x plus 5 minus 5 is equal to negative 5, and since I took away 5 here, I got to take away 5 from this side too. So my reason here for step 3 is addition property, or subtraction property, I guess. Adding a negative, same thing as subtracting, but we'll call it the subtraction property. Alright, property. Alright, make sure I spelled that right. Alright, subtraction property. Good. Now, I'm going to go ahead and in my fourth step combine like terms. So now I'm left with a 2x is equal to negative 10. Now where did I get that? I combine like terms. Like terms. And then let's go ahead then and look at step 5. And what I'm going to do is I want to get rid of that 2. I want to get x by itself. I want to get x is equal to negative 5. So now I'm going to go ahead and divide both sides by 2. And that was the division property. Now if you want to say multiplication property, that's fine. Or rather than dividing by 2, what we're doing is we're multiplying by its reciprocal 1/2. So it's really up to you in terms of which one you write. I think both are kind of correct. Step 6, I'm going to simplify, and I'm going to end up with x is equal to negative 5. My final reason for why I got that answer, simplify. So the reason we do proofs, and some of you are probably thinking that right now, this seems like a really thought out process. That's the purpose of a proof. The purpose of a proof is to start with something that's given, to write down a set of logical steps and reasons to why we know that this is the correct answer for this given information. And really think about this as like the story of how you solve problems. Whenever a teacher asks you to solve something, there's always steps or reasons of why you do it. This is just kind of formalizing that and writing out those reasons. If I were to pick up your work, or if somebody else were able to look at this, they would clearly see how to kind of go from step to step. And really you're creating a log of how to do every single problem you've ever done. Alright? So we tried example 1. Let's go ahead and slide to the next page for example 2. Remember, if you're feeling confident or you feel like, I can do this, Mr. Ausel, well, that's fine. Just go ahead and pause the video, try it on your own, and then kind of watch as I go through it and correct any mistakes that you might make. Remember, mistakes are where all the fun happens, so it's good to make mistakes. Let's look at number 2 together here. The first thing I'm probably going to do is obviously write down the given information. So I'm going to start with 4 times the quantity c minus 1 is equal to 16. And the reason I'm going to write that is that it's given. Step number 2. I see a set of parentheses here with a 4, so that makes me think I want to distribute. So I'm going to multiply the c by 4 and the negative 1 by 4. And what I'm going to end up with here is the distributive property. That's my reason for doing that. Property. That's a U, not a V. Distributive property. Alright. Oh man, screwed up my numbering there. Let's fix that real quick. We want to make sure our numbers line up. It's a good practice and a good mistake to make on your notes just so you guys can see it. Now I'm looking at statement 3, and since I want to move that 4 over, let's go ahead and use that additive property. We're going to take away 4, so we're going to add 4, and what I do to one side I have to do to the other with the additive property, addition property. Step 4, we're going to combine like terms, so I'm going to get a 4c is equal to 20. Combine like terms. And now let's go ahead and let's use that division property. And we have 6 steps, so we're just going to add a 6 down there too. Now extend that line a little bit. Alright, so 4c, let's get rid of that 4 by dividing by 4. So I'm going to use that division property. And there might be other names out there that you've heard for these different types of properties. Sometimes you'll be hearing, like when we're simplifying here to get c is equal to 5. You might have heard like, Mr. Austin, I'm pretty sure that's called like the multiplicative identity. Yeah, that's also kind of correct. So We're not going to be too nitpicky at this point on what properties you're using, as long as you're giving a reason for everything that you're doing, and also you're following this pattern or this setup. So if you want to use the multiplicative identity here, that'd be fine, but we just want to kind of help you through learning the process. We always want to make sure, as we're doing these problems, I don't think I mentioned this in number 1, is that my final statement has to match what I'm trying to prove. And my original first statement has to match what I was given. As long as those things match up, you're doing the proof correctly, because you're starting and finishing where you want. The work in between, that's where you get all the points. So you gotta make sure that you're following your steps correctly. Alright, so in number 3 here, we're looking at a different problem. We're given something where we have 2 fractions and we know that we want y to equal 10. We just have to kind of figure out how to get from a to b, or from given to prove. So let's look at our first statement, which we all know at this point is just rewriting what was given to me, and also saying that that was given. Alright, and now let's go ahead and try number 2. Now, people call this different things, and you can kind of decide on what you want to do to call it that. Something that we've always talked about at our school, and the way we kind of teach it, is this idea of cross multiplication, by multiplying the denominator of one fraction with the numerator of the other, and vice versa. So when we do that, we end up with 10 times y minus 2 is equal to 8 times y. And the reason for us to get that answer is by cross multiplication, cross multiplying. Alright, now step 3. If I'm trying to solve for y, the next thing I might do is use my distributive property. So I'm going to get 10y minus 20 is equal to 8y, using the distributive property. And then step 4, let's use our addition property, and let's combine like terms to both sides. First thing I'd probably do is go ahead and, since there's a negative 20 here, let's add 20 to both sides. Property. And let's also go ahead and then use also the, let's get the y's on the same side, so let's use our subtraction property. We'll do 10y minus 8y is equal to 8y minus 8y plus 20. Now you might write better, you might have better handwriting than I do, and I'm running out of space here, but make sure you write small enough that you have enough room for all these steps, because we are going to go up to 8 steps in this problem. Starting with number 6 here, let me just extend this line so we can kind of continue the process here. Alright, number 6, after we've done that, we'll combine like terms. So this is going to be 2y is equal to 20. A lot of writing. Alright, now in step 7, what we're going to do is we want to get the y by itself, because we want y equals 10. So let's use our division property and divide both sides by 2. And our last step, step 8, we're going to simplify. So we get y is equal to 10. 8, we get y equals 10, so that was simplifying. That was our reason for doing that. Or simplify. Alright? So, again, proofs, they are kind of long and can be written out, but again, they provide a logical argument for why, if we start with this, we can prove that this is going to end up here. And we're going to use that a lot this chapter and in chapters moving forward, just to understand the relationships that angles have with each other to form different types of polygons and specifically triangles. So, hope you enjoyed this lesson. You can go back and rewatch it anytime. Also, make sure that you're trying, if you're in our classes here at Stonebridge, make sure you also try examples 4 and 5 on your own, 4, 5, and 6, and check them with the key that's going to be posted on your teacher's website. Alright, thanks again for watching the video, and we'll catch you later. Bye.